Hello everyone, welcome to IIT and Gate classes. I'm Mukesh Kumar and today we'll be going through the communication system problems that were asked in Gate 2020 for electronics and communication. So first let's just go through how many questions were asked and how much marks each carried. So the total number of questions that were asked in 2020 based on the communication system was 8 and the total marks they carried was 12. So it is 12% of the, so it carries the 12% of the total 100 marks, and that is significant. So if someone want to score very well, then this is a very important subject as well. So let's go through the first question. So this is a question that were asked, first question that were asked in the communication. So this is more of a probability question than a communication question. So here we are asked to find out the probability that the received block is erroneous. So what is given here? So here we are transmitting the signal, which is a block of n bits, and probability of the error in decoding is 1 bit. So this is 1 bit probability of error in 1 bit, and the error event of the each event are independent of each other, and the probability and the received block is declared erroneous. So received block is of n bits. So the received block is declared erroneous if at least one of the bit is decoded wrongly. Okay, so we need to find out what is the probability that received block is erroneous. Okay, so to find out, we will first find out what is the probability that the received block is correct, and the one minus of that will be the probability that the received block is erroneous. So we have a block, block of n bit. Okay, we have a block of n bit, and probability that each of one bit is an error is alpha. Okay, now let's find out what is the probability that all of them are received correctly. So probability that n bit block is received correctly. Okay, so that will be like so we have total n bits, so that will be probability that first bit is received correctly, into probability that second bit is received correctly, probability that third bit is received correctly, and so on till nth bit is received correctly. And here we are multiplying all the probability because it is independent. Okay, because it is independent. So this is a probability that we are receiving the nth bit blocked correctly. Okay, this you can also write it as a 1 minus alpha to the power n, because it is n times multiplication. Now, so the probability that received block is erroneous, so received block is will be equal to 1 minus this probability, and that is 1 minus alpha to the power n. Okay, so this is the probability that the received block is the erroneous. So this will be the correct answer. Okay, now this is the second problem. Here this problem is based on information theory and coding, and this is very easy problem. If you go through the theory, if you already know the theory, you can very easily solve it just by seeing the problem. So a binary random variable x take the value +2 and -2, and the probability that x is equals to +2 is alpha, and probability uh, and we need to find out the value of alpha for which entropy is maximum. So let us go through the theory. So here this is a binary. Okay, and to calculate the entropy H, we need to use this formula that P log 2 1 by P, or let's say P1 plus P2 log 2 1 by P2, and where P1 plus P2 is equals to 1. Okay, This is the entropy where P1 is the probability of first symbol and P2 is the probability of the second symbol. Now it is given first symbol is alpha and second symbol will be 1 minus alpha from this. So P2 will be, so here P1 is alpha and P2 will be 1 minus alpha. Okay, so let's write it. So it will be alpha log 2 1 by alpha plus 1 minus alpha log 2 1 upon 1 minus alpha. Okay, this is the h. Okay, now let's plot this h with respect to alpha. So if you plot it, you will get some curve some that looks like this. Okay, where alpha will vary from 0 to 1. Okay, it cannot go beyond 1 because it is a probability and probability can never be more than 1, and it cannot go below 0 because probability cannot be less than 0. So that's why alpha is just varying from 0 to 1, and if you vary it from 0 to 1, it looks like this. Okay, now here you see this is h is entropy and it is getting its maximum value in the middle, which is 0.5. Okay, so here the answer will be 0.5. Actually, this you don't need to derive in the exam. This will be covered in the theory of the. So just by knowing this theory, you can easily answer this problem. Okay. Now let's go to the next problem. Okay. Here, this is based on the random process and random variable. And here we were asked to find out the variance of y and what is given. So this relationship between y and w is given, phi t is given, and it is known that w is a real wide Gaussian noise process with two-sided spectral density SWF equal to 3 watt per hertz for all f. The variance of y is. Okay. Now, first thing here to note that WT is a real wide Gaussian noise process, so its mean will be 0. Okay, so expected value of W is 0. Its mean is 0 because it is Gaussian white noise. Okay. Second thing to notice is this relationship. Okay, here it can be further simplified as y equal to or yt equal to minus infinity to infinity wt phi t dt. Now phi t is 1 only for t equal to 5 to 7, 0 otherwise. So you can simply write it as a 5 to 7 wt dt. Okay. Now we need to find out what is the variance of y. So variance is given as expected value of y minus mu square. Okay, where mu is the mean of y. This mu is mean value of y. Okay, but here we know that w is mean value of w is 0. So for y also it will be 0. Okay, we will simply write it as expected value of y square. Okay, now this can be calculated from expected value of yt yt plus tau, which is a autocorrelation of E. This is rxx, sorry, ryy tau. This is autocorrelation of y. Okay, if you put tau equal to 0, ryy tau, and put tau equal to 0, it will be simply expected value of y square t. So that will give us the variance. So first let's calculate what is the Ry by tau and then put tau equal to 0 to get here. So expected value of yt yt plus tau. Okay, so let's assume that this t is t1 and this t is t2. So t1 is t and t2 is t plus tau. Just let's write it like this. So write it like yt1 yt2. Okay, the difference between t1 and t2 is tau. Okay, now we know the relationship between this y and w. So let's go to next slide. So let's clear this and let's go to next. and annotate here. Okay, so here we need to find out expected value of yt1, yt2, and yt we know it is 5 to 7 wt dt. Okay, so I can write this as a expected value of, here it is yt1 into yt2. I can replace this y with this w, integration of w, 5 to 7 wt1 dt1 into again 5 to 7 wt2 dt2. Okay, now let's write it as a expected value of 5 to 7, 5 to 7. This two integration I'm just bringing closer, and wt1 wt2 dt1 dt2. Okay, we can further write it as a expected value of 0 to 7, sorry, 5 to 7, 5 to 7. Let's take this expected value inside wt1 wt2 dt1 dt2. Now you see this term expected value of w1 t1 and wt2. It is nothing but a autocorrelation of w. Okay, so I can write this as a 5 to 7, 5 to 7 integration r w w tau, where tau is the difference between t1 and t2. So tau is difference between t1 and t2, absolute difference. That's why there is a mod, and write it as a dt1 dt2, or you can write it as a 5 to 7, 5 to 7 r w w t2 minus t1 dt1 dt2. Okay, now we need to know what is the rw tau. Okay, so our spectral density is given, that is 3 watt per hertz. Okay, that is white noise, so it will be constant across the frequency, and it will be 3 watt per hertz. This is the as WWF is given. Now we know that as WWF is a nothing but a Fourier transform of RWW tau. Okay, so we need to just calculate the inverse Fourier transform to get the RWW tau. So this is constant and its value is 3. So we know that whenever this in frequency domain, when something is constant, in time domain it will be impulse. So RWW tau will be del t into 3, because this 3 is there. Okay, so this will be 3 del t. So let's put it here, sorry, del tau. Okay, or you can write it as a 3 del tau is t2 minus t1. Okay, so we can write it as a 5 to 7, 5 to 7 del t2 minus t1 dt1 dt2. Okay, let's first integrate this with respect to dt2. Okay, let's first integrate it with respect to dt2. Let's do this integration first. So integration of impulse is unit step. So 5 to 7, after integration I got u t2 minus t1, and limit is 5 to 7 and dt1. You see here the variable with respect to with respect to which I have integrated here is t2. So I will replace this t2 with this limit, that is 5 to 7. So here I will get integration from 5 to 7. This will be u 7 minus t1 minus u 5 minus t1. Okay, dt1. Now this is u7 minus t1, this is u5 minus t1. If you plot this signal, this complete signal, it will be something like this: 5 to 7, its value is 1. For rest of the value time, value is 0. Okay, so this value will be 1 only for 5 to 7. Okay, there is one thing missing here. I missed a 3, this 3. Okay, this 3 will continue. So this 3, okay, so 3 into 5 to 7, and its value is 1 from 5 to 7, dt1. This will give you 3 into 5, 7 minus 5. That will be 3 into 2 equals to 6. Okay, so here I got the value of rxx, this ry by tau. So let's clear it. So I got ryy, sorry, yeah, mm, tau is equals to 6. When you put tau equal to 0, this r tau will be this this r0 will still be 6. Okay, so that will be the variance. So this is the answer. Okay, now let's go to the next problem. Okay, this is again a probability based question. So here the two-sided fair coin is labeled as 0 and 1. The coin is tossed 2 times independently. M and N are denote the label corresponding to the outcome of the tosses. For random variable x, defined as x is equals to minimum of M and N, expected value of Ex. So here we need to find out what is the expected value of Ex, which is given as summation of xi pix. Okay, I is varying from whatever the like how many samples you have, that based on that. Okay, so here we have only two values, 0 and 1. Okay, so let's write them as a m and n, and they can take four different values. So there will be four different possibility, both are 0, 0, 1, 1, 0, and 1, 1. Okay, now what will be the x? So x is nothing but minimum of m and n. So here minimum of m and n is 0. Here again minimum of m and n is 0. Here also minimum of m and n is 0. Here minimum of m and n is 1. Okay, this is the x. Now what is the probability of this? So probability of getting this equal to 0 is half. Probability of getting this 0 is also equal to half, and they will be independent. So total probability, so probability that both m and n are 0 is 1 by 2 into 1 by 2. That will be 1 by 4. This will also be 1 by 2 into 1 by 2. 1 by 4, 1 by 4, and 1 by 4. Okay, so you see, for x is equals to 0, probability is 1 by 4 plus 1 by 4 plus 1 by 4, that is 3 by 4. For x is equals to 1, probability is 1 by 4. Just put it here. So expected value of x will be, so x is equals to 0 into probability. So 0 into 3 by 4 plus x is equal to 1, its probability is 1 by 4. So answer will be 1 by 4 or 0.25. So here answer will be 0.25. Okay. Now from here on it's 2 marks question. Now this question is very easy, so for 2 marks. Okay, so let's solve this. So we have a modulated signal x is equal to mt cos 2 phi fct. The message signal is 4 cos 1000 pi t, and the carrier frequency is fc is 1 megahertz. Okay, the signal xt is passed through a demodulator as shown in the figure, and here this is the multiplication frequency, so it's a cos 2 pi fc plus 40t. Okay, now let's solve it. So first, here we need to solve this in the frequency domain, not in the time domain. Okay, so this is mt cos 2 pi fc t. Now mt is given as this. So in the frequency domain, you can write this as mf. It will look like 2 impulse located at, what is the frequency? 500 hertz. In terms of hertz, it will be 500. In terms of radian per second, it will be 1000 pi. So it will be minus 500 and 500. This is m of f. After that, I'm multiplying it with cos 2 pi fct, which is 1 megahertz. After multiplication of this, both impulse will shift left and right by 1 megahertz. So 2 impulse here and 2 impulse here. Okay, this is 1 megahertz minus 500. This is 1 megahertz plus 500. This is minus 1 megahertz minus 500. This is minus 1 megahertz plus 500. Okay, this is after the modulation, that is like this is xt, so let's call it as a x of f. After that, again I am multiplying this signal with cos 2 pi fc plus 40. So again this complete signal will again shift left as well as right by this much frequency. Okay, so let's multiply this. Okay, and let's call this signal as a yt. So let's call it as y of f. Okay, now we have to shift each of them left as well as right by fc plus 40, and fc is 1 megahertz. Okay, so let's first take this one and shift it right by fc plus 40. So it will be somewhere here. Okay, here it is at minus 1 megahertz plus 500. So when you shift it right by, so minus 1 megahertz minus 500, we are shifting it right by 1 megahertz plus 40. So this 1 megahertz is this will cancel out, and it will be minus 500 plus 40, which is minus 460. So this will be at 460. This will be shifting right. This also we need to shift it right by fc plus 40. So it will be minus 1 megahertz plus 500 plus 1 megahertz plus 40. Okay. Again 1 megahertz will cancel out. This will be 500 plus 40, that is 540. So this will be at 540. Okay, now let's do this. You can do this for the left sided, but we will not go for it because this low pass filter is going to reject it, because that will be at very high frequency somewhere, let's say some 2 megahertz around here, around 2 megahertz, and that will clearly be rejected by this low pass filter. Now again, let's take the right sided this dual impulse. Again, when we shift it right, this that will get rejected by this low pass filter, so let's not calculate it, just calculate which is shifting left. So again now in this case we are shifting it left by uh, 1 megahertz plus 40. So this 1 megahertz minus 500, we are shifting it left, so subtract it 1 megahertz minus 40. So this and this will cancel out, and this will come at minus 540. And let's again shift this one, and if you shift it, it will be at 1 megahertz plus 500 minus 1 megahertz minus 40. 1 megahertz will cancel out, it will be at 460. Okay, so this is a thing. Now we are passing it through low pass filter, which has got a frequency at 510. So it is somewhere around like this. Okay, so that filter is somewhere here. So it is going to reject this 540 and this minus 540. It is just going to accept this 460 and minus 460. So output will be only at 460 hertz. Okay. So which one of them is 460 hertz? So that is this one, right? 460 hertz on in terms of radian per second, it will be 920 pi. So that is this one. So this is the correct answer. Okay. Okay, this is interesting, Prav. So this is based on the frequency, angle modulation, frequency and the phase modulation. So in this question, phase modulated signal is given, frequency modulated signal is given. Now where the Kp is a phase constant in the radian per volt, Kf is the frequency deviation in radian per second per volt. If the highest instantaneous frequency of SPT and SFMT are same, then the value, then the ratio of this Kp and Kf we need to calculate. Okay. So here it is given that instantaneous frequency, highest instantaneous frequency is same in the both cases. Okay. Now how to calculate the instantaneous frequency? So this is the angle that is, let's say, theta, When you differentiate this theta, you will get a frequency in radian per second, and that should be same in both cases. Okay, so omega equals to, which is in radian per second, is d theta by dt. Okay, so this value should be maximum of this W max of this should be same in both the cases. Okay, so let's first differentiate it and find out what is this omega. So it will be Kp dmt by dt. Okay, this is the differentiation of this one. This maximum value of this should be equal to, now let's differentiate this. It will be simply kf into mt, because here integration of m tau, when you differentiate it, that integration will go away, it will be simply mt. We need to find out what is the maximum value of this. Now Kp, now this complete thing will be maximum when this differentiation of mt is maximum. Okay, so we see that differentiation of mt is nothing but a slope of mt. So slope of mt is maximum at this range, this range. Here the slope is 0, here the slope is negative, and here the slope is positive. So we won't take the negative because that will reduce the value. So we will take the positive slope. So here we need to calculate what is the slope here. So here the slope will be given as y2 minus y1 upon x2 minus x1, that is 10 by 2, that is equals to 5, is equals to kf into, this will be maximum when mt is maximum. So maximum value of mt is 10 here. So it will be into 10. So kp upon kf will be 10 by 5, that is equals to 2. So here the answer will be 2. Okay. Now here this is very interesting problem. This is based on the maximum likelihood. Okay. Here 4 symbol is given, which is -3, -1, +1, and +2. Okay. Receive signal as S plus W, where W is a noise, zero mean variance, uh, zero mean unit variance quotient random variable, and is independent of S. Now PI is the conditional probability of symbol error for the maximum likelihood decoding. Okay, when transmitted, a symbol S is equals to S of I, where I index for the conditional probability, okay, symbol of, okay, where the PI is highest. Okay, so we need to find out which symbol will have a highest probability of error in this case. So let's start. So first thing is that we getting y is equals to S plus W. Okay, where W is the Gaussian noise. Okay, so let's take the first case when it is S1. So y is equals to S1 plus W, or it is a -3 plus W. Okay, so we know that W is a wide Gaussian noise with zero mean and unit variance. So its PDF will look like this: probability density function, Gaussian. Mean is 0, and this is the Gaussian graph. Okay, now we are adding with it -3 plus W. So when you do the PDF of this one, you will get it something like this. It will get shifted by 3. It is -3. So now mean is -3. Okay, because if you calculate expected value of y, it will be expected value of -3 and plus expected value of W. So expected value of W is 0, and expected value of -3 will be simply -3, because it is deterministic signal, not random. So mean value of y is -3, and again this is a Gaussian. Y is also a Gaussian. So this is the PDF of received signal y when we know that we have sent S3. Okay. Now, how do we decide the maximum likelihood? So maximum likelihood is given as Py upon Si into P of Si. So for the given y, whichever has this as a maximum value, we will decide in favor of that. So we try to maximize this. That's what the maximum likelihood tells. Okay, so now similarly, if you do for the s2 is equal to -1, it will be again a PDF which is centered at -1. Then if you do for s3 is equals to 1, it will be again the Gaussian PDF which is centered at 1. And for last one, it will be again the Gaussian PDF which is centered at 2. Okay, now we already know the all the py upon si. Okay, so this is py upon s2, this is py upon s1, and this is py upon s4. Okay, this is -1, so this is s2, this is +1, this is s3 actually, and this is s1 actually. Yeah. Okay, so we have all this PDF, and also here it is written that wait, this one. Okay. Mm, okay, here it's randomly chosen between S and transmitted. It means that the probability of all each of them is same. That is 1/4. Okay. So what we need to do is we need to plot all this PDF. So it will look like this. Okay. So this is -3. This is -1. This is 1. And this is 2. Okay. This is the graph of P of y when we are sending S3 into P of S3. And similarly, this is the graph of S2. Sorry, this is S1. This is for S2, this is for S3, and this is for S4. Okay. Here, now, this is the, if you see this point, this in this point, if you see the left of this point, in the left of this point, this PDF is higher than anyone. Okay. So if received signal y is less than this value, let's say alpha 1, then we will always decide in the favor of S1. It doesn't matter whether we have transmitted S2 or S3. Okay. Similarly, at this point, let's say this is alpha 2. In the below this point and after this alpha 1, this PDF is always greater than anyone else. So if the signal y falls in this range, we will decide in favor of the S2. Similarly, from here to here, we will decide in the favor of S3, and from here to infinity, we will decide in favor of S4. Okay, now here the probability of error will be maximum if, so let's say you are sending S3, sorry, S1. So probability of error will be given as, so this is a PDF and you are sending S1. If this S1 falls in this region, we will have error because we will deciding in the favor of S2, or if it comes here, we will deciding in favor of S3, and if it comes here, we will be deciding in favor of S4. So this will be the area. For S2, area will be this plus this. For S3, area will be this plus this, and for S4, area will be simply this. Okay, now this area will depend if they are closer or not. Okay, here we see the distance between these two is 2. Distance between these two is 2. Here the distance between these two is just 1. Okay, here they are very close. Okay, so if you see the area of this one will be same as the area of this one, and that will be same as area of this one, and this will be same as that one. But here this area and this area will be more than this 3 because here this 1 and 2 are very close. Okay, and because of that, the probability of error in S3 will be maximum. We are not deciding in the favor of S4 because S4 doesn't have on the error on the right side. It has error only here, but S3 has error here as well as here. Okay, so here the most of the error will come in S3, and that will be the answer. So this problem was not of a numerical, but more of an analytical problem. There you need to analyze this. So if you are very much familiar with this PDF, you can easily calculate in within 1 minute itself. Okay. Now this is the last problem. Here the random variable with the uniform probability density function interval on this one. So here we have a random variable x, which is from interval -2 to 10. Okay, so if you plot px of x, it will be from -2 to 10, and since it is uniform, it will be constant. That is what is the uniform random variable. Now since we know that the integration of px x into dx will be equals to 1, because total probability is always 1, it means that this area should be equal to 1, and that will decide the height. So here height will be 1 by 12. Now here we have another random variable y, which is 2x minus 6. Okay, now since x is a uniform random variable, y will also be a uniform random variable. Okay, and here the conditional probability, we need to find the conditional probability of y less than equal to 7, given that x is greater than equal to 5. Okay, now this can also be written as, so we know that pa upon b is pa intersection b upon pb. Okay, this we will use here. So first we need to find out what is the pyy or pdf of y. So when you put x, so to find out, we need to find out what is the starting point of y and ending point of y. So y is equals to 2x minus 6. When you put x is equals to minus 2, which is the starting point of x, so for x is equals to minus 2, y will be equals to minus 10. And for x is equals to 10, y will be equals to 2 into 10 minus 6, which is 14. So y will vary from minus 10 to 14, minus 10 to 14. And again, for this also, area under the curve will equal to 1. So its height will be 1 by 24. Py y. Okay. Now, what will be the probability that x is greater than 5? So that will be, let's say this point is 5. That will be area from 5 to 10. And that will be equal to 1 by 12 into 5. So probability that x is greater than equal to 5 is 5 by 12. Okay, so here we got what is the p greater than x. Now we need to find out what is the probability that p x is greater than equal to 5 intersection y less than equal to 7. Okay, now here we need to see, so x is greater than 5. Okay, so when you put x is equals to 5, what will be the value of y? Y will be equals to uh, 10 minus 6, 4. Okay, when you put x is equals to 6, y will be equals to 6, and when you put x is equals to 7, y will be equal to 8. Okay, and so we don't want to go here because y should be less than 7. So x should be greater than 5, but y should be less than 7. So if x is 6.5, y will be 7. So we need to find out the probability that x is in between 5 to 6.5, or y is in between 4 to 7. Okay, that both of them will be same. So y equal to 4 to 7, this area. So y equals to, this color is bad, this area. Okay, from 4 to 7. So height is 1 by 24. This width is 3. So this will be 1 by 8. Same thing you can calculate it from here. We need to calculate it from 5 to 6.5. So 5 to 6.5. This width is 1.5 into height is 1 by 12. So that this 1.5 you can write it as a 3 by 2. So it will be 3 by 24 or 1 by 8. Both are same. So this is the PA intersection B. So the value of this will be equals to, value of this, which is 1 by 8, divided by value of this, px greater than 5, which is 5 by 12. Or you can write it as a 12 by 8 into 5. Okay, 12 by 40, or 3 by 10, that is zero point 0.3. So the answer here will be 0.3. Okay, so this is the way to calculate this kind of problem. So here we have used this bias theorem to calculate it. Okay guys, that's all for the today. So we have solved all the 8 problem. So let's see you in the next class.